Hi there, Econ 140 students. Today I'm going to go over how to do the first lab. We've talked about this in class, specifically in the last two lectures, but I'm going to go through step by step showing you my screen of how to go through it. And so you want to remember this is lab assignment 1. We'll be using Excel and we'll be using GDP growth rate data from Fred, and we'll be using price data from the Bureau of Labor Statistics Beta Lab Data Finder. I'm going to go ahead and download that data myself fresh from the internet. You are welcome to use the data sets that are already built into Canvas. It's a little bit easier, and then you won't have to go ahead and download it, but I want to go ahead and show you how you would do that just in case. So let's get started. Okay, so the first step is to go ahead and download GDP data from Fred. And Fred is what we call the St. Louis Federal Reserve's website. They have tons of economic data, great resource, especially for macro data, although not necessarily. And I want to look at real gross domestic product over time. The data set that's online goes up to, I think, 2019. This is going to be a more detailed data set. And you can see here they've already created their own graph looking from 1950 up to 2020. And we can see the spikes here, the dip with the global pandemic, negative 31% GDP growth. That's dramatic. Look how much it compares to the Great Recession or any other recession over in our history. And then a period of growth and expansion in the third quarter of 33%. So that's going to change results. If you are using the data set that's on Canvas already, you're going to get, I think, a standard deviation of 3.8. This 30 plus, 30 minus spread here is going to have a really big effect on what we see in our GDP growth rate over time. And so here you can see I can download the data, I can edit the graph. You can also shrink the amount of time you're looking at. So now I'm just looking from the 70s to current. I could also cut out that variability in 2020. And now I see the scales a lot different. I could even bring it a little bit further. And now we have, the scale only goes from 15% to about 10%. But that's not what I'm going to do. I'm going to go ahead, and there's a lot of links for other data here. There's truly just a ton of data. But I want everything because I want a really interesting graph that shows all of the variation over time. So I'm going to click download. I want data for Excel. This CSV file, it's comma separated variable. We'll talk about this when we talk about Stata, but it's another way to use data. It's another form. Usually you can open CSV files with Excel. You can also use them with the Mac program Numbers, although I don't actually like that program. You can also download this data as an image, a PDF, or a PowerPoint, just the graph itself. But I want to download the data set as Excel. So I'm going to go ahead and save that to a file in my computer. And I'm going to save it in, let's see, we'll call this Lab 1. And now I can go ahead and open that data up and begin the lab. So my goals with this data set are to download or to calculate the summary statistics, interpret them, and calculate or generate a time series graph. So the first thing I'll do is I'll put my summary statistics right here, and I'm going to go ahead, and you don't have to do this, I'm going to go ahead and zoom in a little bit, first of all, and I'm going to call this my summary statistics section. As soon as Excel is willing to let me. And then I'm going to have my mean, my number of observations, my minimum, oops, maximum, and my standard deviation. And then I can go over here and start. So the equation for mean is equal average. And then I want to go ahead and select the growth rates going back from, this is from 1947 all the way up to 2020. And the goal here is to get as much data as possible so that you get the most realistic view of what's going on, right? And we can see here, there's not a lot of variation leading up to 2020. And then in the second and third quarter of 2020, we have a massive amount of variation. So we'll see what that looks like. So that's going to give us an interesting mean. So I have a mean of 3.2. Now what's interesting here is even though we had so much variation in 2020, that's still pretty close to the mean you will get with your data set. Number of observations, we can use the formula count. We could also just say, oh, well, it goes from 12 to 306. So I could just say 306 minus 12, but I'm going to go ahead and use the formula for count. And then that's going to go from B12 to B306. Oops, close parentheses. And now I have 295 observations. I want to go ahead and do the same thing for minimum from B12 to B306. And remember, if you do something different, if you delete out an empty space or you get rid of these links, that's going to shift your data set up or down, and that's going to alter what cells you want to name in your formula, because that's what you're doing in these formulas, is telling your Excel program which cells to look at. So now our formula for max to get the maximum value, and here we have, you'll have much smaller mins and max if you use the Canvas data set, right? I think the max is 16.7 and the min is -10. And then the standard deviation, and you can see it pops up. There are a lot of standard deviation formulas. We're just going to use this basic standard deviation formula. And again, we want to go from B12 to B306. Great. So that's a much higher standard deviation than we saw before. So if I wanted to come in here and interpret these, I can select a few cells. And what I like to do is come up here to the top and click Merge Center. And now I've got a nice big text box where I can write what I want to say. The next step I do is go ahead and click Wrap Text, and that way it doesn't go in one straight line, it wraps around. And I can come in here and say the mean value for GDP growth rate in the US. I'm going to go ahead and amend this and say GDP for real GDP growth rate is 3.2, which tells us that the US has, on average, enjoyed positive and relatively strong GDP growth. The minimum and maximum values, they indicate that the spread is the same, right? That we see an equal spread on either side. Periods of economic expansion, and lows, which are periods of recession. The standard deviation, oops, a measure of volatility in the data and is fairly high but is likely skewed by the recent volatility experienced in 2020. There we go. That's a nice little paragraph explaining it. Then the last thing I want to do is go ahead and select this data set and build that time series graph. And again, this is pretty easy. Back in my day, it was a lot more complicated and you had to select the data manually. But here I can select my data, my time periods, and my GDP growth rates, and then go to insert and select a time series graph. And that's going to allow me to generate a graph that will usually, not always, but usually default to giving me my growth rates that I'm looking at over time. And I'm just trying to move this up here right now. I'm going to move it up so it's closer to the top and easier to see. Okay. And that way it'll be right by my analysis. It's not essential that you keep your data in, but I do think it's nice to be able to see everything, and that way I can check your formulas. If your data is not there, especially if you delete it out and you don't update your formulas, you'll lose it. I want to alter my title, so I'm going to say US real GDP growth rate. I don't need to say over time because it's a time series graph, and you can see that down here with these periods. You can see the scale is significant because of that big change, that big shift we saw in 2020. And I can stretch it out if I want to kind of space things out a little bit more. And there's actually a lot you can do with that. So for one example, you can come in here and select these sort of standard chart designs if you want to. We can go in and look at, oops, lost it. We can go in and look at some of the layout options. We can change the colors. We can do a lot of different things with it. So that's exciting. So if I go to chart design up here, I can, add in do a very, very simple graph, which isn't very useful because it doesn't tell us what's going on. I can do something like this. And now it says, there's an axis title up here. There's a title for this line here, but we don't have a lot going on, so that's not really important. I can do something like this. But again, I don't need, with just the simple title, I feel like was the kind of best description of my data for this purpose. So I'm going to go ahead and kind of backtrack to what was closest to what I had originally. And then I can just delete out this box and rename it again. US What I will do is I'm going to go ahead and, because I am a little picky, I'm going to change the colors. So I can you can change the chart type here, which wouldn't be super useful. Let's see, go to format. And now I can do some play around with this a little bit more. You can also select individual data points and alter them. You want to be careful when you do that though, because what you really want to do is try to keep things consistent and simple and not too crazy. So you can see how things get crazy quickly when you start doing things like shape fill and that kind of stuff. Here's something that's great, I think. We can go in and format the axis and change the labels if we want to. So you can go in here and insert labels. You can say where you want the labels to be. You can say what you want them to look at. I want to change the code. I want to format it to be year and month and not have the dates in. So I can go ahead and do that. And that's something that I feel like makes it look a little cleaner. So there's a lot you can do. And the more you get comfortable with it, the more you can do. This isn't really a class about graphing, but I think it is useful to kind of look at what you can and can't do in here. But that's the first half. So I would save this as my oops. I'm going to call this now Lab 1 Walters. I'll call it this. Sorry. Now I've got it. And then I can go ahead and close that out. And then if I want to, I can go to the BLS Beta Data Lab and see if I can pull some price data. So I can go here and go to their labs, or I can just go, let's go from the beginning and start with the BLS. And then here is their beta tool. And there's all kinds of other data here. So there's consumer price index data for inflation. There's employment data and unemployment data, workplace data. There's a lot of data at the BLS, and that's great because this is a government website, so we have a lot of faith in the data that we're seeing here. Let's see where this takes us. So I want to go to the Beta Labs home and data tools and find their data finder. And then go to advanced search. And then I can kind of pick whatever I want to look at. So I want to look at consumer price index data, and I can break it down to urban consumers. There are rural numbers too. We just usually have better data for urban, and there's an urban bias to that, and that's just the nature of it. Let's see. We break it down by products and services. I might want to pull something for leisure. Let's say I want to look at food away from home in the West. And that gives me data from 2018 to 2020, so that's a good start. And I want to click on that so I can select it. And then let's add something else. Let's add something that's not in leisure and hospitality, and not in food and beverage. Let's go to housing, and maybe I want to add to it some kind of measure of the cost of living. So here we have household furnishings and operations, seasonally adjusted, and that's for all the West. And one thing you want to do here if you're doing this is you want to try and keep your region consistent, and that's kind of a tricky part. But if you think about it, I don't want to compare food prices in Clearwater, Florida to housing prices in Washington or in Arlington. And then maybe I want to go here into this, and I want to look at maybe not household pricing and observation, but maybe I want to look at, let's see, let's add in medical care commodities or professional services, and then let's add in something else. Let's go ahead and break it down by geography so I can stop looking at places like Alaska. And so this is a lot. But what you can do is spend some time in here and find a lot of really interesting stuff. So now I can look at, I've got professional services in the West. And I can go over here and look for something else in that category. So here we've got, let me get rid of some of these to get a little bit more data. This is a pretty boring video right now. I've got medical care, commodities, and let's go in and look for education and see what we can find there. And we can add tuition and fees. Now let's look at all those data sets together and see what I've got. Let's see what I have here. So I've got a bunch of different data sets. You can see here, they've got different lengths, different values, and I can again download them as Excel or download them as comma separated variables or CSV files. I'm going to go ahead and use a Excel file, mostly because you can't do graphs very well in a comma separated variable file. I'm going to save my original data just in case something goes wrong, so I have it. And I'm going to go ahead and save it here in my Lab 1 folder. And I'm going to say raw price data. Then I can go ahead and open that. And here I've got medical care commodities in the West, not seasonally adjusted. And I've got monthly observations for that from 2018 to 2020. I have professional services in the West from 2018 to 2020 by month. I have tuition, which is every half year, so I don't want to use that. And household furnishings by half year. And the reason I don't want to use those two is not that they're not interesting, but if I do, to match them with my other monthly data, I'm going to have to cut a lot of stuff out. And also there's not enough observations here, right? My minimum number of periods for this census, according to the assignment, is 8 periods. This only has 1, 2, 3, 4, 5, 6. So hopefully, the CPI for food away from home is also by the half year. So what I'm going to do is I'm going to go ahead and cheat and pull out the data I pulled with you guys in class last time, where I've got apparel, and I'm going to go ahead and do what I did in class. And I'm going to pull this data. I'm going to go ahead and, well, first what I'll do is I will copy this worksheet and put it in my data set. And I'm going to go ahead and say, put it in this data finder raw price data page and create a copy. And then I go over here and now it's in this same folder. So now I've got apparel, I've got medical care, and I've got professional services. And now I can get to work. So I'm going to go ahead and select the data for professional services, and I'm going to copy and paste it into a new sheet. And I want to call it professional services. And then I can go ahead and get medical care. And I want to keep the data information just to make sure everything lines up until I'm 100% sure that it does. And rename this medical care services. And then I see, okay, January 2018, May 2019, December 2020, those line up. I can delete that out. And then last but not least, I have apparel. And I want to make sure I've got that info. I'm going to copy it, paste it, and make sure the dates line up, which they do, all the way down to December 2020. So I can delete out the dates and put in here apparel spending. Now I want to create my consumer price index. And remember, what we want to do here is generate an unweighted index. And in this case, it's not that unreasonable, right? We've got apparel spending, medical service spending, and professional service spending by month. So that actually makes sense. If we're looking at apples, bananas, and kiwi, or gasoline, rice, and wine, then we might see something else. But really what we want to do is just get that formula in here of, I want to add together all of the prices for my goods, and then divide them by the prices in the base period. And for the first one, it's going to be the same, as the numerator will be the same as the denominator, right? Because I'm looking at the base period, which is why the first year is always 100. And then if I want to, I can go in and say, okay, the next year I want to take, or the next month I want to take February prices and divide them by January 2018 prices. But the other thing I can do if I want to do the drag, if I want to drag that formula, is I can go ahead and, let's see, instead of this, I can go ahead and insert in that equals, or that dollar sign, and that dollar sign is going to tell Excel to only change the numerator, not the denominator. So I go in and I say, don't change this because that's my base year. Okay. So I'm going to say, dollar sign B2, dollar sign 2, plus dollar sign C, dollar sign 2, plus dollar sign D, dollar sign 2, times 100. And now, when I pull that equation down, it's going to go ahead and keep my base year constant. That's what that dollar sign means, and only update the numerator. Otherwise, it would be updating the numerator every time. So I can go ahead now and pull this, and it's really easy to get as many periods as I want. If I want to do the whole entire thing, I can. Okay? And I can generate the time series graph that I want for this. And so I can collect, or just select that CPI data, and then insert a time series graph like we've done before, and I'll pick a simple one. And then one thing I want to do is go ahead and select data and add in my horizontal axis label right here. And that's going to be the date. Okay, and I'll click enter, and that'll pop that in and populate that. Okay. And I can even go in and change this label to date. And that way, if I want to use a label there, I can. But that gives me an unweighted CPI. I can talk about how prices fluctuate, how it looks like over here in 2019, we see a pretty big spike we see a pretty constant increase in medical care services, but there's a spike in 2019, and that might be driving that CPI up. We also see a spike in apparel in spending in late 2020 or in early 2020, and then a drop thereafter. So those are the kinds of things you could say if you wanted to interpret the data. And when I ask y'all to interpret data, I'm just asking you to get used to thinking about data, what it means, and what you could say. So I can save this as Final Lab 1 Part 2, and then save this as part of my lab, and then submit those. You could put both worksheets into one Excel file. That's also fine. Whatever you want to do. So there you go. Hope that helps. If you have any questions, let me know. Otherwise, I'll see you next time. Have a great rest of the day.